Good evening, all of you. Is my voice clear? And video also? Thank you. So, let us begin our today's session. The last part of the conicoid chapter, what we are going to discuss. So, the definition here is so we are discussing about the definition of diameter plane. I think, have you heard the word diametral line earlier in an ellipse? Did you study that earlier? Yes or no? Right? However, we discuss the same concept again. So, if you consider an ellipsoid whose center is nothing but origin. So, in this ellipsoid, you consider a set of chords. You are considering a set of chords there. So, if you try to find a plane equation which passes through the middle points of all these chords, so whenever we consider a system of chords in an ellipsoid, so for each chord you have the midpoint. So we are going to calculate a plane equation which passes through the midpoints of the chords. Such type of plane we are calling it as the diameter plane. Okay? Is the definition part clear? And in general, we use the formula of tangent plane for the calculation of diameter plane itself. So if you take the conicoid, what is the formula we use? Axx1 plus Byy1 plus Czz1 is equal to 1. This is the equation of the tangent plane we consider, isn't it? So here also the same formula we use to calculate the diameter plane. One interesting thing is, since the diameter plane passes through the center of the conicoid or ellipsoid, which is nothing but the origin, so it will not contain the constant, so we will take 0. So this is the equation of the diameter plane in general. So we just write the equation of the tangent plane, in which apart from taking 1, we take 0. That is nothing but the equation of diameter plane. Okay? Are you clear with this definition part? Now, we discuss about the conjugate semi-diameters. And interesting thing is, I think in 2016, questions are framed on this part, conjugate semi-diameters. If you take two semi-diameters, please understand, their lengths are different. You are taking the different lengths of them. So if you consider semi-diameters, they are called as conjugate semi-diameters. If you consider diameter plane of one, it passes through the other. However, we are solving problems very less on semi-diameters. our interest is somewhat different while doing the problem sessions. So if you consider an ellipsoid, how to calculate the respective plane equations and what are the properties satisfied by these semi-diameters, that we are going to discuss now. That is our main interest for today's class. So let us take the part that you have taken an ellipsoid x square by a square plus y square by b square plus z square by c square equal to 1. The ellipsoid equation. Now, if you consider the three coordinates where you are getting the conjugate semi-diameters, just like say this is the ellipsoid, center is nothing but origin O. So I am taking 3 points OP, OQ, and you can take OR also. So you visualize this part in 3D. So you can just imagine that, suppose if you have taken a basketball, at its center you are taking 3 lines, the semi-diameters inside of it. Are you getting the idea? How we are taking the semi-diameters inside the ellipsoid? Right. So if you take that, the endpoints are x1, y1, z1, x2, y2, z2, and x3, y3, z3. Let us say OP, OQ, and OR are nothing but the conjugate semi-diameters. What I am taking are conjugate semi-diameters. So they will satisfy certain kind of properties. So you can consider the respective diametral plane equations. At the point P, the diametral plane is nothing but x1 by a square plus y1 by b square plus z1 by c square equal to 0. Yes, please understand, if you take circle, we can call upon radius, because if you imagine the circle, from its center, all the points are at equal distance. Agreed? Right. So, but if you take an ellipsoid, horizontally, vertically, diagonally, if you measure the distance, they are different inside of the part from the center. That's why the semi-diameter concept is different. We can treat it as radius if the semi-diameters what you have taken horizontally, vertically, and diagonally are of equal distance. In that sense, we treat them as radius, but otherwise they're always different in general. Right. I think you get the concept. This is taken as horizontally and this is vertically, this is diagonally. Inside the part of a ball, you can imagine. Right. So, if you imagine that this is of the form Lx plus My plus Nz, if you imagine, it's just like a plane equation, the tangent plane equation, however. So, the coefficients will satisfy certain kind of properties. So, whenever you consider the 3 conjugate semi-diameters drawn from the center of the ellipsoid origin to the points P, Q, R, if you consider the respective diametral planes using this formula for each point, they will satisfy certain kind of properties. Those properties, I am listing them now. You please take a note of them. While solving the problems, these properties are very much useful for us. Okay? You take a note of them. I am going to list out them. So one property is x1 x2 by a square plus y1 y2 by b square plus z1 z2 by c square equal to 0. You take 2 pairs. This is one set of properties. Then we have the other properties also. Since the points are lying on the ellipsoid, they will satisfy the ellipsoid equation. That is, by default, we can understand from them, right? So I am not writing them separately again. Another properties are nothing but this is one set of properties. Again, you have the property that so if you observe that the properties what I have written are just like similar to the properties of direction cosines. Please understand that the properties what I have written are somewhat similar to the properties of direction cosines. That is one set of properties. And you have one more property that so please take a note of these values first. Then I go to the other part. Please take a note of them. After noting, you please tell. Take a note of them and inform. So shall I continue then? Right. So one interesting property is, yes, we have taken 3 conjugate semi-diameters. If you consider their sum of the squares, it is nothing but OP square plus OQ square plus OR square. If you consider this value, it is nothing but a constant. It is very easily verified. How? OP is nothing but distance between origin and P. So it is nothing but square root of x1 square plus y1 square plus z1 square. If you consider OP square, it is nothing but x1 square plus y1 square plus z1 square. This is square root of and this is normal. This is OP square. Accepted? Similarly, if you consider the other distances OQ and OR, it is nothing but x2 square plus y2 square plus z2 square and x3 square plus y3 square plus z3 square. This is OP square, OQ square and OR square. If you consider their sum, if you add them, so as I have mentioned, sum of these three values is a square, this is b square and this is c square. So you get the value as a square plus b square plus c square. It is nothing but a constant value because ABC values are constant. So sum of the squares of any three conjugate semi-diameters is a constant. That is one result, you take a note of that. After noting, please tell. Have you finished with that? Right? So another one is, suppose I have taken an ellipsoid, say 3x square plus lambda y square plus z square equal to 1. This is an ellipsoid. And I have taken that it has three conjugate semi-diameters. So what is lambda value here? That was the question. Are you getting the idea? Yes or no? And one more condition in the problem given that if you take the sum of the squares of the conjugate semi-diameters, it is 0. So I have taken an ellipsoid. It has three conjugate semi-diameters like this. If you consider sum of the squares of the three values, it is 0, then find lambda value. So if you rewrite the given equation in the form of ellipsoid, it is nothing but x square by 1 by 3 plus y square by 1 by lambda plus z square by 1 is equal to 1. So comparing with ellipsoid equation, so a square is equal to 1 by 3, b square is equal to 1 by lambda, c square is equal to 1. So just now we have proved that the sum of the squares of the conjugate semi-diameters is nothing but a square plus b square plus c square. In the problem, the value is given as a equal to 0. So you substitute respective values there and give me the value of lambda. What it could be? Yeah. Is lambda value 3 by 4 or minus 3 by 4? Please tell. Is everyone getting the context? What I am saying, how it is calculated? So lambda value is minus 3 by 4. So please understand that in this problem, it is mentioned that sum of the squares of these values equal to 0. You can take other point also. Suppose if you take that the value is equal to 2, then you will get another lambda value. It is based upon the question. Fine? Are you clear with this? Yes? I have converted the given problem into ellipsoid. Then I have written that. Because if you want to use the formula based on this, you should know what is a square, b square and c square, isn't it? Otherwise you cannot solve because we are doing the problems based on that. Right. If you have noted this, I'm going to take the other one. Shall I? The next problem. Right. So one interesting thing is, if you observe that the three conjugate semi-diameters I have taken, the 3 points are on the ellipsoid. So what happens if I try to calculate a plane equation passing through the 3 points? So if I have considered the 3 conjugate semi-diameters of an ellipsoid, I am trying to find a plane equation passing through the 3 points. So what could be its locus that I want to find? So this concept is very much interesting while solving the problems. So first of all, let us take that Lx plus My plus Nz is equal to P. This is the required plane equation which is containing the 3 points P, Q, R. So if I have known what is L, what is M, what is N, then I am done. Accepted? I need to get the values of element here. Since the 3 points are lying on the ellipsoid and also the plane, so let us substitute the points here. So Lx1 plus My1 plus Nz1 is equal to P. Lx2 plus My2 plus Nz2 is equal to P. And again Lx3 plus My3 plus Nz3 is equal to P. So one interesting thing is, I want to eliminate element here. For this, earlier I have written some of the properties of these diameter planes, etc., etc. So keeping view of those points in my mind, I want to multiply first equation with x1, second equation with x2, and third equation with x3 that I want to do actually. Then I am going to add them up. So what happens if you multiply first equation with x1, second with x2, third with x3, and you add, you will get the respective value as you accept it all? Please check the value. I have multiplied them with the respective values and I have added the 3 equations. First, second, third, then I will get the result like that. Please check on that. If you have any queries, you can ask. So my intention is, after writing this plane equation, I want to know what is L, what is M, what is N. I have to find the values of element. That is my main intention. So for that, I have done that multiplying the equations with x1, x2, x3 respectively, and I have added them. I will get this kind of thing. Are you getting the context? Yeah. Since this value is nothing but a square, from the properties you have noted, this is 0, this is 0. You got that L is equal to P into x1 plus x2 plus x3 by a square. That is one value you got. Similarly, what happens if you consider these three equations, you multiply with them y1, y2, y3 and add them up. Just like what you did now, you do the same thing, multiply first equation with y1, second equation with y2, third equation with y3 and add them up. So then you will get that m is equal to p into y1 plus y2 plus y3 by b square. Similarly, if you multiply with them z1, z2, z3 and add the equations, then you will get n is equal to p into z1 plus z2 plus z3 by c square. So these are the values of lmn we got. Here, this value is nothing but a square. I have written the properties earlier. Can you recollect the properties from the diametral plane equations I have written? I have given set of conditions earlier to make a note of them in the beginning of the session. So the coefficients in the diametral plane will satisfy the properties of DCs just like that. So whenever you multiply different values, they become 0. Whenever you multiply the same values, you will get the coefficients. This is a square, another one is b square, another one is c square. I have written the conditions earlier. Did you recollect them? So this becomes 0, this becomes 0. So from this L is equal to that value divided by a square. Right. Similarly, I got the value of L while multiplying these three plane equations with x1, x2, x3. Now what happens if you multiply these three plane equations with y1, y2, y3 and add them, you will get m value. Similarly, if you multiply with z1, z2, z3, these three plane equations, and if you add them, you will get the value of n, like this. Is the perception clear now? How I am getting the values of element? Right. Now, the final part is, in the required plane equation, I am substituting the values of element. So, the final answer is I am going to write it down. You please take a note of it. So x by a square into x1 plus x2 plus x3 plus y by b square into y1 plus y2 plus y3 plus z by c square into z1 plus z2 plus z3 is equal to 1. So you have to by heart this equation. You have to remember this because many of the problems we are going to solve on this model, keeping view of this plane equation. So after substituting element values, we will get this type of thing. If you have noted, please inform. I am going to take the next problem. So please remember this plane format. It is very useful while solving the problems. Shall I proceed then? Okay. Now the problem is, prove that Please take a note of the question, then I discuss with the part. Is it noted? Right. So it is very simple and easy problem. Suppose this is the plane passing through the 3 points P, Q, R. So obviously what happens? This plane will be satisfied by the 3 points. So substituting the points in the plane, we have Lx1 plus My1 plus Nz1 is equal to P. Lx2 plus My2 plus Nz2 is equal to P. Again, Lx3 plus My3 plus Nz3 is equal to P. Right? Now, what happens? In order to get the required locus in the problem, what I am doing is, you do squaring on both sides each equation and you add them up. So you take the first equation, squaring on both sides, second equation, squaring on both sides, third equation, squaring on both sides. So this is a plus b plus c whole square form. It is also same form, it is also same form. If you add the three values, on the right hand side, you will get 3p square. Right? So I will write the expression part. If you take the terms as common, you will get the expansion value as L square into sigma x1 square. Since place is insufficient, here sigma x1 square is nothing but x1 square plus x2 square plus x3 square. Please understand. I think you will understand the abbreviations. M square into sigma y1 square plus n square into sigma z1 square plus you have 2mn into sigma y1 z1 plus 2nl into sigma z1 x1 plus 2lm into sigma x1 y1 is equal to 3p square. Okay, as you know the properties of the diametral planes earlier, so this value is a square, this value is b square, this value is c square, the remaining values are 0. This is 0, this is 0 and this is 0. And right hand side you got 3p square, which gives the required locus. That was the solution. A square L square plus B square M square plus C square N square equal to 3p square. You take a note of that. Shall I proceed if you have noted that? Right. So let us do something interesting. So the next question is, prove that the pole of the plane PQR on the ellipsoid is you take a note of that. In other words, prove that the locus of pole of the plane PQR on the ellipsoid is this. After noting the problem, you please tell. Is the question part clear for you? What we are doing actually here? Right. So this is the ellipsoid. Yes, by putting the 3 points, we will get the answer. Again, I will tell you the way how we are going to solve this. So if you have taken the ellipsoid having 3 conjugate semi-diameters, and I am considering a plane which is on the ellipsoid, so that on this plane the 3 points are there, P, Q, R. So this is the plane having the 3 points P, Q, R. Now what happens? I want to consider the pole of it. I think you know what is meant by pole. I hope so. Right. So what happens? In the first place, as per the previous problems discussion, whenever you take an ellipsoid having 3 conjugate semi-diameters, OP, OQ and OR, the equation of the plane is nothing but this equation. So in the first place, we have to write the entire plane equation, and you have to obtain this plane equation first. That is step 1. Clear? In the exam, you have to write this part again. The deduction of this part, how this plane equation has come. Now, let us take that the pole is alpha, beta, gamma. This is the pole. So as per the problem data concerned, we have to show that the locus satisfied by this pole is nothing but this equation. So we have to show that alpha, beta, gamma satisfies this equation. So what we need to achieve? Alpha square by a square plus beta square by b square plus gamma square by c square equal to 3. That we have to bring. Are you getting the content? Say yes or no. Now, whenever a pole is given, we will calculate the respective plane for it. We have a specific formula, nothing but the tangent plane formula we use. You can call it as a polar plane, plane of contact, tangent plane, whatever the word may be, we use the formula of tangent plane. So what is the tangent plane equation here? It is nothing but alpha x by a square plus beta y by b square plus gamma z by c square is equal to 1. This is the equation of the plane having pole. You can call it as a polar plane. Now what happens? Our required plane must have 2 things. 1, it must be the polar plane. 2, it is passing through the given points PQR. So let us say that these 2 planes are similar, the same, because we have to find a plane equation having 2 conditions. 1, passing through the points PQR. 2, it must be the polar plane. That's why this is the polar plane equation. This is the plane passing through PQR. Let us compare them. Suppose these 2 are same. What happens? Then let us compare the respective coefficients. You compare the coefficients of alpha, beta and gamma there. So if you compare the coefficients, I will say that here, in other words, you can say if you are taking the coefficients of x by a square, y by b square, z by c square, because these things are there. So you have alpha by x1 plus x2 plus x3 is equal to beta by y1 plus y2 plus y3 is equal to gamma by z1 plus z2 plus z3 is equal to, we need to compare the constants, nothing but 1 by 1. Here the coefficient is 1, there also the coefficient is 1. So what I am saying, I am comparing these two planes so that they are the same planes, hence respective coefficients must match. So from this you can say that alpha is equal to x1 plus x2 plus x3, beta is equal to y1 plus y2 plus y3, and gamma is equal to z1 plus z2 plus z3. So please take a note of this part and tell if you have any doubts on this. Right. Now see, as per the problem data concerned, this locus we have to bring. It is our target. So for this purpose, I mean, we have to show that alpha, beta, gamma will satisfy this locus. For this purpose, as you know, the values of alpha, beta, gamma, based on the locus condition, I will simplify that. So how I am doing? So you take squaring on both sides. And first one, you divide with a square. Second one, you divide with b square. Third one, you divide with c square. So I am considering alpha square by a square plus beta square by b square plus gamma square by c square. It is nothing but x1 plus x2 plus x3 whole square by a square plus y1 plus y2 plus y3 whole square by b square plus z1 plus z2 plus z3 whole square by c square. So in the numerator, if you expand the terms, as you know, the properties of the diametral planes, from that properties, you will get the value as a square by a square plus b square by b square plus c square by c square plus 0 plus 0 plus 0. The values, nothing but 1 plus 1 plus 1 equal to 3. So the required locus is obtained here. The locus is nothing but x square by a square plus y square by b square plus z square by c square is equal to 3. This is the required locus. Please take a note of that. After noting, please inform. Any questions for anybody? Yes or no? Right. I will take the next problem then. So the next problem is prove that the locus of center of section of ellipsoid by the plane PQR is the ellipsoid take a note of that. Then we discuss. After noting, please tell. Right. The approach for this problem is very similar to the previous problem, what we did just now. So here, I got a plane equation PQR, and it is mentioned that center of section of ellipsoid by the plane. You just imagine the case that suppose you have taken a ball. Say this is an ellipsoid, the ball. You take a knife, the plane PQR, you chop it. Then what happens? You will get a section, isn't it? Yes or no? Is everyone getting the concept of my visualization? I have taken an ellipsoid, with a knife I am chopping it. So I will get a section of it, the part. So for that part, you will get a center, a point. So he is saying that that point satisfies this ellipsoid equation. In the other words, by taking that point as a center, we can construct another ellipsoid whose equation is this: x square by a square plus y square by b square plus z square by c square equal to 1 by 3. That was the whole idea. Is it fine? Say. Right. So in the first place, the equation of the plane PQR is nothing but this plane equation. So you have to write the procedure as it is. The equation of the plane passing through the points PQR is nothing but this. You can mention this plane equation directly. Now, what happens? Let us take alpha, beta, gamma is the center of the section. As and when the plane intersects the ellipsoid, you will get a section. For that section, let us take, this is the point alpha, beta, gamma. So in other words, the point alpha, beta, gamma lies on the given plane PQR. Accepted? And it is passing through the ellipsoid, say? Yes or no? So, whenever a point is given, the equation of the ellipsoid, the equation of the plane is nothing but alpha x by a square plus beta y by b square plus gamma z by c square is equal to, right side, the constant is taken as so this is the equation of the plane which gives the section. I will repeat once. So for a better visualization, you take a ball. In that ball, you insert a cord. A plank you insert. You will get the section, isn't it? Whatever the shape may be, you will get a section on the plank. Accepted? Right. So for that intersection part, you will take the center. the center point you consider. Say, if this is the ellipsoid chopped by a plane, you will get a section here. This section, you take this is the center. This center point satisfies this ellipsoid equation that we have to show actually. Fine. Are you getting or not? Right. So, whenever you take a plane passing through the points P, Q, R, it is nothing but the plane equation in the standard notation. We have to use this plane always. So, I got a new point alpha, beta, gamma here, the center. As and when I know a center, I can construct a plane equation passing through the center. How it is? If you take this is the ellipsoid center, so this is the plane I am getting. So at this spot, you are calculating the plane, nothing but tangent plane you say. If you take tangent plane, it lies on the outer surface. If you take the plane inside the ellipsoid, so what happens? Alpha x by a square, beta y by b square, gamma y by c square is equal to the distance. Distance from center of the ellipsoid to this plane must be equal. Then only you will get the exact section. That's why the right side constant is written like this. If you have written that alpha x by a square plus beta y by b square plus gamma y by c square is equal to some p square. That p is nothing but the length of the perpendicular we use. So this is that. The value. Clear? So in this way I have written the plane equation. Right. Now let us compare the two plane equations just like the previous problem. This is the plane, this is the plane. Let us compare the respective coefficients there. What happens? So I am going to compare the coefficients in the respective plane equations. So it is nothing but alpha by x1 plus x2 plus x3 is equal to beta by y1 plus y2 plus y3 is equal to gamma by z1 plus z2 plus z3 is equal to, right side you have this constant alpha square by a square plus beta square by b square plus gamma square by c square whole by 1. This is the constant 1 here. In the previous problem also, I have compared the coefficients of x by a square, y by b square, z by c square. On comparing the coefficients, I will get required locus. Here also I am doing the same thing. I have considered the plane PQR. I have considered a tangent plane equation like this. For both the planes, I am comparing the respective coefficients. So if you compare the respective coefficients there, you are going to get the values as, I will make space here. So alpha by A is equals to x1 plus x2 plus x3 by A into the value. And you take the other one, beta by B. And you take the other one, gamma by C. This is the part. So what happens? I have to show that the required locus is nothing but That is my required locus satisfied by alpha, beta, gamma. So I have to show that alpha square by a square plus beta square by b square plus gamma square by c square is equal to 1 by 3 that I need to show. So for this, as I have known the values of alpha by a, beta by b, gamma by c, let us square them. So take a square of it. Again square that. Again square that. So if you add the three values on the right hand side, the terms gets cancelled. As per the diametral plane properties you have written, only 1 by 3 will come. That's the thing. That is nothing but the solution of the problem. Okay? All other values gets cancelled. In a nutshell, what we did, I have written the plane equation PQR. I have written the tangent plane equation based on the distance. I compared the two plane equations, coefficient of x by a square, y by b square, z by c square. From that, I have got the relation that alpha value, beta value, gamma value. Actually here, alpha is equal to x1 plus x2 plus x3 into this part. So I have divided both sides with a. And to get the required locus, I have done squaring on both sides and I have added them. That is the thing actually I did. So as per the locus, we are doing necessary changes in the equations what we obtained. So if you have noted this, I have one more problem to discuss that will be also interesting for you. I am going to discuss that. Then we can finish our today's session. And I will give subsequently the material which you can understand on your reading, because you have done so many problems with regard to conicoid. Similar phenomena and similar logic you are able to understand. That I will give you separately. And the assignment also. And from tomorrow's session onwards, we will start abstract algebra, the new concept, which comes under paper 2. So if you have noted this, you please inform. I start a new problem. Are you getting confused with the approach what we are doing actually here? Or is it comfortable to understand the idea? Not getting 1 by 3. So I will say that you will get the part as alpha square by a square plus beta square by b square plus gamma square by c square is equal to whole square into 3 you will get. So the square gets cancelled, the value is nothing but 1 by 3. So if you take squaring on both sides and if you add them, you will get the relation like this. So from this, you will get that alpha square by a square plus beta square by b square plus gamma square by c square equal to 1 by 3. Substituting here, you will get the required locus. That's it. Now it is clear? Right. Yeah. Let us discuss one more concept. Again, I will redraw the picture. So far, I am taking the only one picture for your understanding. So let us redraw it again. So this is the ellipsoid with center 0. So OP, OQ, and OR. Say. So let us consider the problem. I think it is also given in the previous year papers, the problem what we are going to discuss now. You take a note of this problem, then we discuss. Right. So here also you are considering the plane PQR, which is passing through the extremities of the diameters, nothing but the conjugate diameters what you have taken. So one more thing here is you have to calculate the locus of foot of the perpendicular from center of the ellipsoid to the plane. So for a simple visualization, if you say this is the ellipsoid and this is the plane, from ellipsoid center to the plane, I am taking the normal. So at what point the plane meets it, the foot of the perpendicular? The locus of the foot is this equation that we have to show actually. Is the idea clear? If you draw from the center 0, 0, 0 to the plane PQR, a perpendicular line, the normal, you will have the foot of the perpendicular. So the foot of the perpendicular, which is lying on the plane, satisfies this equation that we have to prove. Okay? Is the visualization possible for you? All of you? Any questions? Right. Then let us do the procedure. So since you know what is meant by ellipsoid and what is this thing, so keep in mind the locus equation, what we have to obtain. So I am erasing the problem. May I? Can I erase the statement of the problem? Right. So in the first place, we know what is meant by a plane equation PQR. So this is my plane equation. So just imagine that if this is 0, 0, 0, the center of the ellipsoid, from this I am calculating the foot of the perpendicular. Say n is the foot of the perpendicular. The coordinates of n are nothing but alpha, beta, gamma. I have to show that alpha, beta, gamma satisfies the locus which is given in the problem. Now, the drs of ON is nothing but alpha minus 0, beta minus 0 and gamma minus 0. The drs of ON. So nothing but alpha, beta, gamma. Accepted? Yes or no? The drs of ON, whenever 2 points are there. So if you want to get the actual DCs, if you divide the drs with the length of the perpendicular ON, the distance between these 2 points, if you divide this, you will get the DCs. So DCs are nothing but alpha by square root of alpha square plus beta square plus gamma square, beta by square root of alpha square plus beta square plus gamma square, and gamma by square root of alpha square plus beta square plus gamma square. So these are the DCs. So if you observe that this is the plane equation PQR and this is its normal, the DCs of the normal are nothing but the values. So we know that if you want to write a plane equation, it could be in the form Lx plus My plus Nz is equal to P, where P is nothing but the distance and Lmn are nothing but the DCs. Accepted? Okay. So using that ideology in my mind, and the DC values seems to be somewhat confusing in mind, I will use a symbol here. I will take square root of alpha square plus beta square plus gamma square is equal to a value, say p. So you will get that DCs are nothing but alpha by p, beta by p, and gamma by p. So what could be my respective plane equation PQR? It is nothing but alpha by p into x plus beta by p into y plus gamma by p into z is equal to the value which is nothing but p, the distance value. The formula Lx plus My plus Nz is equal to p I have written. So which is nothing but alpha x plus beta y plus gamma z is equal to p square. Again we do the same procedure. This is the plane passing through PQR. This is the plane containing the foot of the perpendicular. Suppose these two planes are same. Let us compare the coefficient as it is. So in every problem, we are considering the plane PQR in the standard notation. We are calculating a plane as per the given problem, and we are comparing the coefficients of the two planes always. That is the actual thing we are doing in every problem. Okay? Shall I continue? So this is the plane equation containing the foot of the perpendicular, alpha, beta, gamma. So you compare the coefficients on two sides. So I will make space here. So if you compare the respective coefficients there, you will get that so I have taken the coefficients of x, y, z. Here x coefficient is alpha. Here x coefficient is this value by a square. Here y coefficient is beta. Here y coefficient is y1 plus y2 plus y3 by b square, like that. So I have taken an x coefficient, y coefficient, z coefficient is equal to constant by constant I have taken. Please take a note of it. So if you simplify these values, we will get the respective thing. So how I am going to get that? So from the first part, you can say x1 plus x2 plus x3 is equal to a square alpha by p square. y1 plus y2 plus y3 is equal to b square beta by p square. z1 plus z2 plus z3 is equal to c square gamma by p square. This is the thing I got actually. Again, I want to simplify that. How can I simplify that? In other words, I can write like, for the simplification part, to get the required locus, how can I do? Yeah, you can write the part as a square, b square, and c square is equal to this. Let us do squaring on both sides. or I can say right. So I have taken the respective values equivalent to, I have done squaring on both sides. This is the net result I got. Now I am adding all the three values, all the left side values is equal to all the right hand side values. So if you expand them, all the terms gets cancelled, we will get the required locus. That is nothing but the whole idea. So first equation, second equation, third equation, you add them. All the LHS values, all the RHS values. Then the terms gets cancelled. The required locus in the problem we will get. The required locus in the problem we will get. So here, for p square you have a value, alpha square plus beta square plus gamma square. Because p is nothing but distance from origin to the point alpha beta gamma. So if you substitute p square value, you will get the required locus. That's it. So actually, you will get the value as from that point a square alpha square plus b square beta square plus c square gamma square is equal to 3 into p power 4. You will get actually. So this is nothing but 3 into p square whole square. So nothing but 3 into alpha square plus beta square plus gamma square whole square. That's it. So x, y, z or alpha, beta, gamma, the point is satisfying that locus. There is a solution we got actually, as per the problem locus is concerned. Is it clear for everyone? Because p square is nothing but the distance from origin to the point alpha, beta, gamma. P is the length of the perpendicular from origin to alpha, beta, gamma. Alpha, beta, gamma is foot of the perpendicular. If you have a small doubt, you can say this is 0, 0, 0. This is the point alpha, beta, gamma. This distance we are calling it as p. So p square is nothing but distance between these two, alpha square plus beta square plus gamma square. I have substituted here the value. Okay. There is the solution part as we consider. Yes. So 3 into x square plus y square plus z square whole square is the locus. If you substitute x, y, z in place of alpha, beta, gamma, they are the required locus. It is nothing but given in the problem. You can check on that. The locus is given in the problem statement. I have erased it already because of the length of the problem so far considered. So that's all for today. If you want to add something, you can add upon for the total solid geometry. I want to take some of the feedback from you. So on what sessions you get bored, on what sessions you will get interesting, etc., etc. And if you want to have more light on some of the topics, what are they? Or the material in particular you want, what are they, etc. With regard to solid geometry, because we are finishing that now, the part of solid geometry. So is the solid examples are sufficient for you to get the idea or the concept? How we are doing actually while taking the problems? Or you want more number of examples to do in the class sessions? Assignment I will give a very good assignment for you, comprising of all topics. My intention is if you once get rid of the syllabus, then at your free time, you are going to solve each and every problem by verifying your class notes and the books, whatever are available for you. Definitely I will give a good assignment for you. Don't misunderstand me. Apart from that, what you want to do more in the class sessions? Is the discussion sufficient for you in getting the context? All of you, please tell. Chapter test, once the syllabus is finished, we will conduct a topic test. We have a test series pattern separately. For each chapter, I mean abstract algebra, analysis, linear programming, complex analysis, everything, we will conduct topic test. Later we conduct grand tests. We have a separate pattern there for that. So first we concentrate on syllabus completion, because there is no guarantee that all the students, while doing the class sessions itself, they will finish the syllabus. They will complete their preparation. You cannot give guarantee. So at their free and convenient time, they are going to prepare the syllabus. So first we concentrate on the completion of syllabus. Later we conduct the test series for you exclusively, keeping view of the mains timetable. So prior to that, either 4 months or 5 months before the commencement of mains, we start a test series. You can participate in that, which concludes topic tests as well as the grand tests, just like the pattern of UPSC. If you want to assess yourself with regard to a particular chapter, assignment is enough for you. There is no need to conduct a separate test and getting the marks. Okay. So for that purpose, we are encouraging that to solve previous year question papers, which is nothing but a test for you. Are you able to solve each and every question from that? Then you are done with regard to your preparation as well as the class discussion is concerned. Okay. If we are interested specifically, then definitely we conduct the chapter test. Don't worry. If once you finish with the assignment, we will conduct a sufficient test for you as per your requirement. So anything you want? Then thanks for everyone. Thanks for your cooperation and good listening.